Good morning, afternoon, or evening. We are the Jumping Amazing Super Optimistic Mercury Squad, and we will be presenting to you Mercury is a major air pollutant, its sources, effects, and control technology. So the objective of this project was to study and quantify mercury emissions from coal-fired power plants, alkaline chlorine processing centers, and waste incinerators, both medical and municipal. We're going to look at their associated regulations and environmental and health impacts. The scope of this study will span across the life cycle of different forms of mercury involved in each process, as well as control technologies associated with them. And we're going to be focusing primarily on America. So mercury is a naturally occurring toxic heavy metal, and it becomes a toxic pollutant when released into the air, water, or soil by anthropogenic activity. While natural global emissions account for 70% of total mercury emissions, anthropogenic activities still contribute approximately 30% of those total emissions. A few examples of anthropogenic sources are coal-fired power plants, medical municipal waste incineration facilities, and alkaline chlorine processing facilities. Once released into the atmosphere, mercury has the potential to cycle through a variety of forms: inorganic, elemental, methylmercury, and other organic forms, each with its own array of negative and environmental health impacts, or negative health and environmental impacts. And there's various efforts that have been made to reduce mercury emissions from each of these processes. So mercury occurs in a variety of forms, like I just said: elemental, ionic, inorganic, and organic. And it's really not just an atmospheric problem. We need to consider the fact that often these atmospheric emissions will affect other, biosphere, lithosphere, aquasphere, or hydrosphere. For example, atmospheric mercury can accumulate in water bodies via precipitation or deposition and affect water quality. Mercury accumulating in streams, lakes, or estuaries can be transformed into methylmercury through microbial activity, which is of particular concern due to quite a few very negative health impacts. The amount of mercury in the forms is largely a function of sources nearby, national, and then also the naturally occurring mercury in the soil and the soil's physical, biological, and chemical properties. This is Harrison, and we'll start off by talking about coal-fired power plants. Coal-fired power plants are the dominant emitters of mercury, or anthropogenic mercury emissions, accounting for 50% of all emissions. And they're also currently the dominant form of energy production in America, accounting for 39% of all of our energy. Fossil fuels are combusted to generate steam, which then powers turbine generators. And one of the considerations is what type of coal you use. Variations in coal grades have different variations in concentrations. For example, coal taken from the Appalachian North Mountains can have concentrations as high as 0.24, 0.27 parts per million. That's a bituminous coal, whereas areas in the Raton Mesa can have as low as 0.04 parts per million to 0.09 parts per million, and that's also a bituminous coal. Despite the fact that there is readily available technology, still 40% of current coal power plants lack advanced pollution control, and that's primarily a function of money, but we'll discuss some of the pollution control techniques later on. Next, we'll be talking about waste incineration, both medical and municipal waste. There's three different forms of, or primary forms of medical waste incineration. Those are controlled air, excess air, and rotary kiln, each with advantages and benefits. Controlled air is the primary use, and then there's also municipal waste incineration. Mass burn facilities are the primary form of this, but there's also modular systems and refuse-derived fuel systems. Why do we incinerate medical waste? Primarily to treat it. You get some energy benefit, but most of it's just for the sake of treating the waste. But in a lot of medical processes, there's mercury waste, so that volatilizes that and emits it as fumes. Municipal waste is a function of both saving space and producing energy. Technologies and very strict emissions have reduced emissions from both of these sources by 95%. They used to be up around about 55 tons per year, and now they've been dropped to 2 and 1 per year, respectively. And finally, we'll be talking about alkaline chlorine processing, and this involves the use of brine, or a sodium chloride solution, to produce chlorine, sodium hydroxide, and then also hydrogen for different industrial uses. There's three different processes: the membrane, diaphragm, and mercury process. Again, each has its own benefits and disadvantages. Mercury cell process produces the cleanest and purest chlorine, but you also have to worry about the mercury waste that's associated with it, whether there's volatilization or just mercury emitted as waste in solid or liquid forms. Fortunately, in America, we focus primarily on the diaphragm cell use, and 79% of our alkali chlorine processing is makes use of diaphragm cell process. Europe still uses primarily mercury cell processes. So you kind of have to look at costs versus environmental costs later on.
Hi everyone, my name is Jared Lorzell. I'll be talking about the health effects, symptoms, and methods of exposure for the various forms of mercury. So we have consumption of fish containing methylmercury, the inhalation of elemental mercury vapor, and direct dermal contact. For the purpose of this class, direct dermal contact will not be discussed. It's not really air pollution focused, but the reason we're even mentioning methylmercury health effects is because elemental mercury in the atmosphere is tied to the formation of methylmercury in the water and land through deposition. So even though this presentation is geared towards mercury as an air pollutant, it would be prudent of me to discuss the health impacts elemental mercury has, even if it's converted to a different form. So the health factors of mercury are dependent on form, dose, age, duration, method, and then the relative health. So the difference between an older person that's sick as opposed to a older person that's not sick is going to be, the differences will be there. Also with children, effects are more pronounced. So the health effects are dependent on the form. Methylmercury, you get the classic symptoms of mercury poisoning, which is cognitive thinking. You start to lose vision, and your motor and spatial skills are severely impaired. Elemental mercury is a little bit different. You see the point there that has insomnia, but it also affects your respiratory, cardio, and gastrointestinal tract. So with respiratory, you're going to see chemical pneumonia, fever, chills, and headache. With cardio, you're just going to get an increase in your heart rate and hypertension. And with gastrointestinal, you're going to taste a metallic taste in your mouth, salivation, and nausea, which usually follows a large exposure to elemental mercury vapor.
Hello, my name is Brennan Schneider, and I will be talking about mercury emissions. Now, when we look at this graph, we see these dark areas represent the largest emissions of mercury. And if we see that Southeast Asia and India are the darkest red, meaning that they emit the most mercury in the planet. They are very, very dense in their mercury emissions. They have large populations, but not necessarily the best mercury emission control technology, which is why we see a lot of mercury emissions here, probably from coal-fired power plants. We also see a lot in Western Europe and the United States, but we also see a few hotspots in South America and Asia as well. Now this shows the world's emissions as of 2010. Now, between 5,000 and 8,000 metric tons of mercury were released into the atmosphere in 2010. And these are accounted for by anthropogenic and natural emissions. Natural emissions account for most of these emissions, but anthropogenic sources contribute to about 30% of total global mercury emissions. Anthropogenic emissions account for approximately 2,000 metric tons of the total mercury emissions. This is a breakdown of the emissions per category. You can see that on a global basis, or global understanding, the artisanal and small scale gold mining represents the largest fraction of mercury emissions from a sole category. Now we'll look at the United States breakdown later, and we'll compare that to the United States. But also notice that coal combustion is the second greatest contributor to the worldwide mercury emissions. This is a graph of the United States, their mercury emissions, and we see that. First, as we talked about later, the artisanal gold mining, that was by far the largest contributor to global mercury emissions, or anthropogenic emissions, is at the bottom here, right above the total, is not even, it's almost negligible. It's so small compared to the total. and in 2011 it was negligible compared to the 49 tons of mercury emitted by the United States that year. If we look at the utility coal boilers, those are our largest section of or contributor to mercury emissions, and they've decreased by more than 50%, but still even now in 2011 they remain more than 50% of our emissions. Now in 1990, 1993, municipal waste combustors and medical waste incinerators were also almost as much as the utility coal boilers. They were second and third, but we see that between 1993 and 2002, there must have been regulations or control technologies in place to greatly reduce both of these. And it seems that from looking at the medical waste incinerators that these were completely just not in use anymore. But the municipal waste combustors were reduced significantly from 1993 to 2002 and continue to be reduced up until 2011.
For air regulations on the federal level, we have the Clean Air Act of 1970, which regulates 188 air toxins, mercury being one of them. It establishes technology-based standards for certain sources of these air pollutants, including mobile and stationary sources in certain industries. Sources are required to obtain an operating permit and comply with all of the emission standards, and mercury is deemed as a hazardous air pollutant and is therefore controlled under the National Emission Standards for Hazardous Air Pollutants. Then we also have the Resource Conservation Recovery Act, or RCRA, and that requires the EPA manage hazardous waste from cradle to grave, meaning from generation all the way to disposal. And RCRA is responsible for setting the emission standards for combusted mercury-containing waste, and this can be found under Title 40 of the Code of Federal Regulations in Section 61. Then we also have the Emergency Planning and Community Right to Know Act, and this requires that industrial and federal facilities report emissions of chemicals, including mercury and mercury compounds. Examples of these facilities would be manufacturing, metal and coal mining, and electric utilities like the burning of coal and oil. Reporting is done through the Toxics Release Inventory Program. And then we have the Mercury and Air Toxic Standards, which is designed to significantly decrease mercury emissions from coal and oil power plants. This includes power plants that supply greater than 25 megawatts from the burning of coal and oil, and all new coal burning plants will have numerical emissions limits for mercury as well as the other hazardous air pollutants. And existing sources will have 4 years to comply with these new standards, and the goal is to reduce mercury by 90%. On the state level, we have the Florida Department of Environmental Protection and the Division of Air Resource Management. The Office of Air Management is responsible for managing air resource, air quality monitoring, permitting, and compliance of emission sources. And Florida, like many states, has adopted the federal regulations, including RCRA's national emission standards for hazardous air pollutants. And these laws can be found there under the Florida Administrative Code. And for regulations in the workplace, we have the National Institute for Occupational Safety and Health, or NIOSH. Their job is to develop safety and health standards in the workplace, and they do research and have experimental programs to ensure that they're consistently developing new criteria for standards. And the governing law within NIOSH is the Occupational Safety and Health Act of 1970, and this main priority is to ensure that workers have a safe working environment to protect human resources so that no workers will experience diminished health as a result of their job. And their standards include exposure to mercury vapor shall not exceed an 8-hour time, an average limit of 0.1 milligrams per meters cubed. Employers must select and provide appropriate personal protective equipment, and it's mandatory that no employee be allowed to consume food or beverages in an area that is exposed to mercury. Right now we're going to pass it off to Stephen, who's going to tell you about control technology.
So this is Steven, and I'll be talking about control technology for mercury emissions. The two major power sources that we have been discussing are coal-fired power plants and solid waste to energy plants. The coal-fired power plants are a much higher emitter of mercury due to just the vast expanse of how much we use coal in this country compared to waste to energy. And so while waste to energy will be covered, the focus will be more towards coal-fired power plants. The ways in which we try to control emissions of mercury in this country as well as others are treating the coal. We try treating the coal and then having a higher coal rating. You always want to have a better coal rating. It will lead to less emissions. And then we have different control technologies that will be discussed. For coal treatment, there are different ways in which we can add things or take things out of the coal to make them more efficient. One of those ways is coal washing, where it minimizes ash as well as sulfur. Beneficiation is another method of cleaning, and it is a similar process to coal washing, but there is a dry and a wet process. Either of those can be used. The dry process is just scraping and trying to get off some of the non-coal products that are on there. In the wet process, it's ground down and then sprayed to have a better removal. Blending and coal additives are another way that we treat coal. These additives and blending of things encourage chemical transformations to reduce the emissions of mercury. The coal rating, obviously anthracite being the highest, lignite being the lowest. The amount of mercury that comes off of anthracite is significantly less than lignite, just due to the fact that it's a much more pure substance of coal, and you want the greatest efficiency for your coal, and so anthracite is a way to do that. One of the control techs that is widely used in the United States is activated carbon injection. This takes carbon and inputs it into the system. The active sites bind with the mercury, and it can clean it up at times. It can assist in the PM, NOx, SO2 little system, as well as being used with a fabric filter. For the combined PM, NOx, SO2 reduction system, mercury is taken out in different ways, and it's taken out in different forms. Now, a catalytic reducer and a electrostatic precipitator will take out different forms of mercury while also taking out NOx and SO2, and the PM also has different PM control devices have different ways of taking it out. In the next slide, I will show you how this looks in a combined system. So this figure gives us a better overall view of what it looks like. There's a catalytic reducer, there's an electrostatic precipitator, wet flue gas desulfurization. All of these will take out mercury in different forms. The ESP takes it out in particulate form, the catalytic reducer takes it out in elemental, and the wet FGD takes out some of the HD2+. And these are all different ways of limiting mercury and taking it out of the system in its different forms.
Alright, so in conclusion, mercury is a naturally occurring element, but high levels of exposure can lead to serious health concerns, mostly with methylmercury poisoning. We have seen a large quantity of mercury emitted from artisanal gold mining and coal-fired power plants, but fortunately we have been able to pass legislation and use control technologies like activated carbon injection to significantly reduce the United States mercury emissions and make the world a healthier place to live.